Hey guys, well I've been meaning to do an overclocking video for quite some time now, so this is it. It's really in depth, so stick with it. Let's check it out. Hi guys, and welcome back to Wikepeadia I. So like I said in the introduction, I've been meaning to do an overclocking video for quite some time. I haven't had the time to do it, so this video is the culmination of about a week's research, if you like. So it's not going to be like your normal overclocking video where you basically go in, set an XMP profile for your memory and up the core multiplier. Although essentially that's what I've done to overclock my machine. But what I'm going to do is I'm going to go into the AI tweaker in my Asus UEFI. And don't worry about that, you know, you'll be able to use these settings in any board you've got. They'll all have similar kind of things. They might have a different name, but it'll be very, very recognizable. And I'm going to go through all those settings, because I think a lot of overclocking tutorials, like I say, they just go in and they say, you know, set your XMP profile for your memory to this. You know, if you've got Skylake, whatever, blah, 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 set your core multiplier to, you know, 44 at 1.32 volts and you're good to go. And that's it. And that's great because you get a really fast overclock. Like, don't get me wrong, that's fucking, that is so good. Sorry, I nearly swore there. That's brilliant. But there's a lot of other features in there that no one really touches on. And and also there's another thing you can do. You can overclock your base clock if you don't have an unlocked chip. So, like I say, I'm just going to go into the UEFI BIOS and I'm going to go into AI Tweaker and I'm going to go through all the individual settings, and then at the end I'm going to give you my settings that I'm running at the moment, and I'll show you how to do a quick overclock. If you don't want to stick with it, once we get into the UEFI BIOS, I will put a little card up in the corner and you can click that and it'll take you right to the end just for a basic overclock. So don't worry, you don't have to go through it. I mean, it's probably going to be a 25-minute long video, so it's quite long. I don't expect all of you to stay with me for that 25 minutes. You've probably got better things to do. But I hope you do stay with me because I think you might learn something. I certainly learned stuff when I've got a big stack of notes, because there were features there I had no idea of what they did or how they would affect an overclock, if they'd affect an overclock. So I found the whole process really interesting. So guys, we're going to jump into the BIOS right now. Hey guys, so we're in BIOS. So you this is my machine, so you just kind of get dumped into the screen here. Hopefully it's okay. It's kind of ghetto. I'm using my webcam to record this just now, and I'm recording the audio on something else. So where are we going to go? So you want to go down here. You want to go to advanced mode, basically. So let's get in there. And then we want to go to AI Tweaker. This is where you're going to go. So as you can see, I'm running at 4.2. My memory is running at 2166. Cache is running at 3.1. And my target frequency is 100 megs. That's base clock. You don't have to worry about that. So as you can see, like, loads of people just kind of talk about like CPU strap, which is basically your base clock frequency, essentially. So when you look at overclocking, I'll just whiz down here. Loads of people kind of look at, they won't touch this base clock at all. You can if you want to. It's a bit more difficult. What they'll do is they'll go to multi-core enhancement and they'll put that to auto. They'll sync all their cores and basically they will set their limit to 42. Like their multiplier essentially will get set to 42. And then you just take your base clock, which is there, and you multiply it by 42 and it gives you 4.2 gigahertz, which is fine. I'm not complaining about that at all. I think that's absolutely fine. I mean, to be honest, it's a really easy way of overclocking. I'm not complaining about that. I just think there's a lot more to overclocking than simply going in and just messing around with a couple of settings like that. As you can see, there is like tons of stuff you can do. So where are we? CPU core voltage. So there's lots of stuff down here, guys. So I'm literally going to go through these settings and just let you know what they do. Like I said, this is going to be quite a long video. You know, so AI Overclock Tuner. This is the other thing you can do. You can go in here, so AI Overclock Tuner, and you click that, and you can set it to auto, which means that the motherboard will do everything for you. You can set it to manual, which unlocks a hell of a lot of stuff further down, and you can tweak to your heart's content, or you can set it to XMP. So I've put it to XMP because my DDR4 has an XMP profile. There it is, 2667. I'm actually running 2133 memory, I think, and then I've just put in the XMP profile, and it's lazy. I could get more performance if I wanted to out of this, but by tweaking these, but I don't see the point. I'm just letting you know that's fine, because these speeds aren't going to limit my overclock at all. Well, that's one thing to bear in mind. If you've got really bad slow memory or just really unstable memory, that will limit how far you can overclock, essentially. AI Overclock Tuner. So you can set that to manual if you want to, and that will allow you to adjust the base clock manually. So this will make the CPU strap, source clock tuner, PLL selection, the filter PLL, the base clock frequency, and the initial base clock frequency when it boots available. So by simply doing this, it unlocks all this other stuff down here. So base clock frequency, initial base clock frequency. I'm going to stick that back to XMP, because although it doesn't really matter because I can just reload my settings afterwards, guys. So moving down, CPU strap. So a lot of people get really confused about CPU strap. But basically, CPU strap changes the reference clock frequency supplied to the CPU and memory in comparison to other components on the motherboard, okay? So this setting is multiplied by the applied CPU core and DRAM ratios to obtain the operating frequency of each domain or each other process on your motherboard. The default setting is always 100 MHz, which results in a one-step CPU ratio change, producing a 100 MHz change in the processor's operating frequency. So like I said earlier on, if you set, we've scrolled down, actually I should use the keys. So if you set, where are we now? See, this has changed, so I'm gonna change this back. I'm gonna go for, turn them 48. Oh no, not 48, 42, sorry. 42. What is wrong with me today? 42. Oh my god, that would absolutely fry my 42. And because, yeah, let's think of the course. So if you've got this set to say 38, that means that all that's going to do, it's going to go and look at your CPU strap frequency and multiply that by 38 and get 3.8 gigahertz. Equally, if you set your strap to 125 megahertz and say your multiplier set to 44, it means you're going to get 44 times 125, which is 5.5. So basically, I wouldn't really mess around with that. 100 megahertz is definitely preferred, unless for some reason you've got memory which has a really odd XMP profile which specifies something specific for, say, the stability of the memory in general. So what's next? Source clock tuner. Again, I would leave that at auto. A lot of these things you can just leave it auto, guys, but essentially all this does is it offsets the reference clock for the DMI bus to help keep it within the stable limits when changing the base clock. So if you're adjusting the base clock, you're probably going to have to set this to, well, it would depend. I would probably go for about 70 to begin with. You can leave it to auto, and it means the motherboard will look after it for you. PLL changes. Now this can be important sometimes, so mine's on auto. So PLL changes the oscillator mode. So the options are LC or SB. So if I click on this, you can see LC and SB. So LC uses an inductor and capacitor based oscillator, while SB uses a shape based oscillator, hence the SB. So there are pros and cons to this. So basically, if you're going to use LC based, it has a lower jitter, but it also limits the frequency at which it will run, whereas SB has a better range in terms of frequency, but increases the jitter in the signal. So if you're going to run 100 megahertz CPU strap, leave it on LC if you're doing this manually, and the default base clock. If you're going to use SB, you basically want to change the base clock back to default. You don't want to mess around with it. And like I say, normally you can leave this to auto. I've never found it makes a huge difference. So let's move on. Like I said, guys, I'm sorry, this is going to be a long video. So filter PLL, basically this can just be used to improve the memory stability when you change the base clock frequency. That's pretty much it. So low base clock, high base clock. So if you set, so if you're going to underclock this using the base clock, you'd hit low. If you're going to overclock it using the base clock method, you put it to high, and that should hopefully stabilize your memory for you. I'm just going to leave mine at auto. Finally, we get to base clock frequency, and essentially base clock frequency is the reference clock supplied to the CPU, the uncore, the memory, the PCIe and DMI buses. Hence, if you make any changes to the base clock, it's going to affect pretty much everything else within your system. So unless you really need to base clock, overclock, like with some Xeons, and you could do it with some of the Skylake chips, the non-K series Skylake chips when they first came out, until they released a, a core code update that won't let you do it anymore. But you could update, well, you could overclock those Skylake chips by changing this value here. So you would leave like your multiplier at whatever the stock was, say 36, but you would crank this up to say maybe 110, and you get an extra 360 megahertz out of it. You can't do that anymore, but there are Xeons out there that you can do that with, like the latest edition Xeons. They're not unlocked anymore. Like my Xeon rig behind me has an unlocked core multiplier, so I don't have to bother with this. Initial base clock frequency is basically that. It is the initial base clock speed that is supplied to the CPU when it's doing post. So that's it, when it's doing power on system checks. You can mess around with this if you want to. Like for instance, if I go and turn this to, if I turn it to auto, manual, sorry. So I go manual and I scroll down here. It's easier to use this. Where are we now? Base clock frequency. So yeah, you can type in whatever you want. 1212, whatever, 100. I wouldn't recommend messing around with your base clock frequency unless you absolutely have to. I'm not saying it's like a bad thing to do, but certainly it can cause problems. But I mean, at the end of the day, the worst thing that can happen is that you don't post. Essentially, you don't get a post. So that's not the worst thing in the world that can happen. So that's basically that. So let's move on to the next one. Asus multi-core enhancement. So basically, whether you've got an Asus board, an MSI board, EVGA board, whatever, most high-end boards will have something like this. And all this does is, it simply, if you turn it to auto, it just applies the turbo ratio to all the cores. That's it. That's all. I mean, it does other things, but essentially that's all you need to know. So you can click on this if it'll let me. Yeah, and you can disable that. So basically all that's saying is, take my multiplier I've set down here and always apply that over all the cores. Similar with this CPU core ratio, sync all cores. That means I'm just trying to sync all my cores to the same frequency. You can do it by core usage, which is quite useful. There are some Windows programs that will let you do that. So if you've got one core or two cores that are really good overclockers, which you might get in a quad core or a hexacore chip, some programs will actually let you specify the core you want to use. By specific core, you can do it with that. And then by core usage just means whichever core is being used the most. So say in some games they're only going to utilize 4 of the 6 threads I have, so it might just dump 2 of the cores down, but it'll actually boost up the other 4 cores, which gives you a bit more thermal overhead, to be honest. It doesn't get the package super hot all the time. And again, you know, this is just a limit. So you can set this limit to anything you want, essentially. And the worst thing that will happen is that you won't get a boot. But because I've got single core set, they're all set to 42, whereas if I go by specific core, I can, you know, select whatever I want for every core. So like if I had one that was a super good overclocker, I might set that to say maybe 4.6 and dump the others 5 back a little bit to maybe 4. And again, it's kind of case usage. It depends what you need, essentially. Right, okay. So now we're getting into the realms of things that I didn't really know about, guys. So I've got a bit more notes on this. So here we go. AVX instruction, core ratio negative offset. So this is going to sound a bit weird because I'm kind of reading this out because I had no idea what this was when I was looking at it. So this setting reduces CPU core frequencies by the applied value when an AVX workload is run. The thermal output of AVX workloads is an order of magnitude higher than for non-AVX workloads, which is why this setting has been introduced. In theory, you can utilize a high operating frequency for light load applications, while heavy load applications that contain AVX code will downclock the processor to help keep the core temperature below the throttling point. So that's it in a nutshell, guys. It's basically a smart bit of technology that will level load your CPU depending on what software is using it. I mean, if anyone knows what AVX instruction code is, let me know, because I have no idea. I've been looking online for a little bit and I couldn't find anything that really gave me a clear description, but to be honest, I've been quite busy doing other things as well. But leave a comment below if you know what that is. AVX, I negative offset. I have no idea. Sorry, guys. The next two are really simple. Min CPU cache ratio and max CPU cache ratio sets the minimum and the maximum core ratio. That's it for when the CPU is active, and that's all it is, basically. So let's keep going. Where are we now? Internal Pll over voltage. I know I'm being a bit thorough. If you don't like this kind of thing, guys, just leave a comment and I will not do a video this long ever again. But you know, I felt like I should do it, and it was fun to learn about this stuff. So internal Pll over voltage basically boosts the internal derived Pll voltage to help enhance the CPU core overclocking margins. That's it. But I kind of messed around with this and I didn't notice any huge benefit to like upping the voltage it was getting, so I would say just leave it alone. Base clock frequency and DRAM frequency ratio, it basically sets the ratio between the DRAM frequency and the base clock. You know, like I say, if you're using an XMP profile or you are leaving it to auto, you're doing a simple core multiplier overclock, you don't need to touch this, just leave it alone. If you're messing around with a base clock overclock, you might have to, you may have to mess around with this a little bit. DRAM frequency is my memory frequency. There you go. So what can I set it to? I don't know what's supported up to. Holy shit. How far? I've not looked at this actually, guys. So I can go to 4,000 on this board. I can see some messing around coming up soon. Anyway, I'm going to keep that same. So TPU just basically applies a preset overclock to the system. There are two options. Option 1 is less aggressive and suitable for air cooling. Option 2 is more aggressive and suitable for water cooling. So you can use that instead of the using their 5-way optimization. I don't know if it's up here. Easy Tuning Wizard. Where is it? So I can't remember. I think if you hit this, it'll take you to another page and you get what Asus call a 5-way optimization, where it does loads of tests on your CPU. I tried that and when it started to say that I should be running my CPU at 5 gigahertz, I turned it off. So I've got mine set to keep current settings because I've got an overclock dialed in, but you know, like I say, you can just do that. You can do TPU2 and it'll give you, I imagine, what would be a reasonable overclock. But we're not going to do that because that's not me. Epu Power Saving, I do not want this enabled at all, because it will basically try and turn your computer into a lean green fighting machine. So which means it's going to limit voltage and all the rest of it. So don't enable this if you're overclocking. Stay well away from it. Disabled is what you want to do. Let's go on. Where am I now? Okay, so I think we've kind of touched on most of the stuff I wanted to talk about. Tweaker's Paradise, so this is pretty cool. So extreme overvolting and things like this you can do. It's disabled at the moment because I'm not brave enough to look at it. Fully manual mode, so I'm not in fully manual mode because at the top, remember, I've got an XMP profile for my memory. The core voltage is manual though, so that's basically the amount of volts you're going to put through your core. So I'm getting 4.2 at roughly 1.35 at the moment. CPU cache voltage is how much voltage you're sending to your CPU cache. Again, you don't have to run this in auto. I've never really found overclocking my cache makes a huge amount of difference, to be honest. I've been doing this for a long time. I've not noticed any huge difference. CPU cache, oh, we just did that. CPU system agent offset voltage mode. Oh my god. Now I have some notes on this somewhere. CPU system agent voltage offset mode. Whoa, now that is a lot to say. So basically, this is responsible for handling the voltage between the I/O and the CPU and other parts of your motherboard. So from an overclocking view, it's pretty important for memory overclocking. Basically what I find is for memory speeds over about 3000, if you're using high density memory kits, voltages up to around 1.3 volts might be required. It depends on how good your CPU memory controller is, I found. I've not found a huge amount of problems, and like I say, I'm only running mine at 2667 and I'm running at 1.184 volts. If I wanted to go a bit higher, I might have to offset this a little bit more, so I might have to go plus. But at the moment, I don't need to, so I'm leaving it. As it's set to auto SVID. I mean, do you need to know about this? I suppose, well, yeah, okay, so CPU SVID support, I suppose we can talk about that. So when it's enabled, it basically allows communication between the CPU's PCU, so the power control unit, and the external voltage regulator for the VCCIN. So this basically allows reading of the CPU power consumption data by software, if you've got some software installed, if you're that bothered. I mean, I don't know. Do you really need to know that? I mean, I suppose if you're doing something super extreme, you might be interested in knowing the exact voltage going to each package on your CPU, but for me, I've never used it. I'm never likely to use it. And again, the SVID support, you know, you need to have that enabled if you want to use it. I've just got mine set to auto. So CPU input voltage is pretty much the voltage going into your CPU from the 1.8 volt direct current from your power supply. I would say the maximum you probably ever want to use is 1.95 volt. I wouldn't want to go any higher than that. I'm at 1.904 volts. And that's set to auto. Like I say, if you set this to manual up here, you can adjust that. But to be fair, unless you know what you're doing, you know, I wouldn't mess around with that. You can get yourself into a world of hurt sometimes. And I mean, at the end of the day, you can go back in and you can reboot, and you'll be fine. Basically, the DRAM SVID support is exactly the same as the CPU SVID support. So if you want to monitor the voltages going to each of your DIMMs, or I don't even know if you can monitor the voltage going to each of the modules in your DIMMs, maybe, I don't know. Again, unless you're doing something super extreme on liquid nitrogen or something, you probably don't need to use that. Let's go down, DRAM voltage. So sets the memory voltage essentially. Surprisingly enough, so I'm running mine at sort of 1.2, which is a bit normal. Nothing exciting there. So this is just for the different channels. So I've got quad channel memory, so that's why there's channel A, B, C, and D. Interesting though that there's so much variation between each side of the CPU. I never looked at that before. I mean, to be honest, it's probably next to nothing when you look at how much it's moving. So Pch Core Voltage. Basically, this just adjusts the voltage for the platform controller hub. You don't need to adjust that. Leave it alone. Yeah, I just wouldn't bother. Similarly with the PCHIO voltage, unless you're messing around and overclocking the DMI bus, I would just leave that alone. You don't need to mess around with the voltage your IO's getting. Never used it, never likely to use it. Where are we now? So again, leave this, don't touch it. It basically controls the rail that's for your IO transceivers within the CPU. If you start messing around with it, the only thing it's going to affect is your memory stability, essentially. So if you're having no problems, don't mess around with it. I've never used this. I've never kind of adjusted anything that would adjust the IO input output for the controller on the CPU, so there's no point in doing it. Similarly with the IO on the back plane of your motherboard, there's no point messing around with that, like I said a minute ago. So let's keep going. Don't mess with this either. It's pretty much the same. It's pretty much the same as this, except it's voltage to the transceivers that control the DMI bus within your system. So yeah, leave it alone basically, unless you want a world of hurt. So VTDDR, so sets the termination voltage essentially for your DRAM. So 50% of the DRAM voltage, if you didn't know, is nominal by default. So this rail will track changes to the DRAM voltage, and I would say it's usually best left alone. I wouldn't bother messing around with it too much. I would just leave that alone again, and unless you're doing something mental and you really want to get those high speeds out of your memory, I don't think there's any point touching it. I think there's a point in knowing about it. Similarly, your Pll termination, Pll reference, and Pll reference offset values, so these ones here, you know, basically all they do is they're small changes. So you can change the termination voltage to your Pll unit, and you can change the offset value that termination voltage will have at the Pll. Unless you're running liquid nitrogen, this is of no use to you. Do not touch these. Just leave them on auto. There's nothing else to do. And again, CPU spread spectrum, sorry guys, leave it at auto for overclocking. So if you enable it, you're probably going to come across instability issues, as the clock modulation will affect the way that your CPU is sampling data, essentially, from the rest of your system. So I would leave that to what it is. Just leave it to auto, guys, and that's it. So that really covers this kind of in-depth part. Sorry about that, this has gone on a bit. But I did say at the start of the video we were going to go through all these settings, because I felt like no one ever goes through these settings. What I'm going to do now is just show you a super quick way of overclocking your chip, essentially. And what you really need to do for what I would say is the main way that most people are going to overclock, and most people are going to overclock using the core multiplier, and that's it. You know, Intel have totally killed overclocking because of this K-series nonsense, and so the only way you can do it is because the chip's got an unlocked multiplier. So let's go down that route. At the end of the day, that's what most people are going to do. So like I say, you get in here, go into advanced like we did before, hit AI tweaker. It's always worth hitting XMP, because you never know, you might have an XMP profile for your memory, which is great, which means you can leave your memory alone. You don't have to do anything to your memory. The next thing you're going to want to look at is CPU core ratio. CPU core ratio, there we go. So like I said, this is totally up to you. But I would do for the CPU core ratio is I would set it to sync all cores. I find that to be the most useful thing to do. That's it. I would hit it at single cores, and then you're going to get the maximum performance you can, depending on stability issues and temperatures on all your cores. Then all you do is go into the top one and set whatever you like. So I would say, if you're running Broadwell E, I would say 4.42, so 4.2 gigahertz is solid and you'll achieve it. I would say if you're running any of the Skylake chips, you want to bump that up to around, I reckon most people would get 4.5 at 1.35 volts. I think. I haven't had a Skylake chip, so I don't know, but what I read, so I would set that to 4.5, so 4.2 for me though. And then we need to go to the CPU core voltage, which is way down here, which is there. So you need to set that to manual mode. You set that to manual mode, and then you can really experiment here, to be honest. It's up to you what you do. You can experiment with a few different voltages. Another mode that's interesting is adaptive. Adaptive mode's pretty cool. So it will actually scale, kind of. If you had a graph, you think of a graph, so X and Y. Y and X. Your voltage would do that as your frequency increased. So it will actually automatically scale that depending on what your CPU is asking for. I'm going to leave it to manual because I think I've got a pretty good overclock set there at 1.35. I mean, I might try, once I get my water cooler in, to mess around with this adaptive mode. There's been a lot of good things said about adaptive mode. So either manual, so if it's manual, you can just use 1.35 is what I'm using for mine, which I think is okay. Again, I think Skylake you can use 1.35 as well. I might be wrong because I've not had hands-on experience with a Skylake CPU. But that's it, guys. Mess around with this. I mean, you're not going to fry your chip just going through the steps that I laid out there. So get into the tuner, set your CPU core ratio. Well, if you've got an XMP profile for your memory, set that. Set your CPU core ratio, set your core ratio limits, and then go and set your voltage, you know, and nothing else is going to go wrong. And that's what I would do. That is basically what I would do. I wouldn't touch anything else. If you guys are interested in baseclock overclocking, I can do a video on that, or you just send me some just send me questions if you want to. Hit me up on Twitter. You can email me at backofbeyondtech@gmail.com. Ask questions in the comments of this video, and I'm happy to give more information on baseclock overclocking because actually it's a lot of fun and it's a lot more interesting than doing this. But in a nutshell, that's how to overclock, guys. It's that simple. And then obviously, you know, exit and save settings. I'm not going to exit and save my settings because my overclock works. So I don't want to mess it up. And that's really the video, guys. So I hope you enjoyed it. I'm really sorry it was so long. I mean, we're getting on to half an hour here. I hope you enjoyed it. I hope it was useful. If it's not useful, if you don't need information like this, let me know in the comments, and I'll happily not spend hours and hours and hours doing this again. But if you did find it useful, then, you know, let me know, guys, because I love the comments. Like, the channel's going through a really good period of growth at the moment. I think there's a lot of really interesting people coming on board, and the questions are getting much more interesting, and, you know, there's a real vibe about it, and I'm loving that. I'm absolutely loving it. So that's it. I'm going to shut up now. That's how to overclock a processor, guys, okay? If you've got questions, leave them in the comments, email me, catch me on Twitter, all the usual things. If you liked the video, like it. If you disliked it, dislike it. But don't forget to subscribe, you know, and don't forget to share it with your friends. Let's get some momentum behind the channel. And I'll catch you again in another great tech video. Bye now.